So what is, basically we're going to talk a little bit about what is JTNM tested, what exactly we've done, why we would do that, what kind of tools we've used to achieve the goals, and what kind of results we produced for the community, both in terms of the tools, methodologies, but also the results, and also some of the conclusions. So actually, to respond to the question of what is JTNM tested, I need to go backwards to the slide. That is, the background is JTNM tested. It's actually, we've taken about 100 engineers from the community, from product management, from kind of developers, and we locked them in the one warehouse, and we said, we're gonna test your stuff. So bring your products, we're gonna test it. And so they did. Surprisingly, to this thread, they actually went and they brought the products. Go figure. So some walls of text that you don't have to read. Scan your badges. You'll get the presentations. And it's also actually, this presentation is already available on the JTNM website. So if you scan one of the QR codes during the presentation or afterwards, you'll be taken to the website where you can find this presentation too. So basically, JTNM tested is a snapshot in time of the state of the industry in terms of compliance to the standards and specifications. So we don't just take the manufacturer's word for granted, saying, "Oh, we support ST2110. Oh, we support NMOS." We actually tell them, "Well, come and show us how you support ST2110 and how exactly you comply to the standards. And if you say that you implement ISO4 API, we're gonna test that, and we're gonna tell you what you did wrong and how you should be ashamed of it." No, of course not. But yeah, so the JTNM tested has three major pillars. So three key areas of every product that we've tested. We've tested the data plane, how exactly they put the essence on the wire. So if they claim to be compatible with, compliant with ST2110, are they really compliant? And we have tools to prove that. Same goes for the control plane. If the manufacturer is claiming that they expose a correct ISO4, ISO5, one of those NMOS specifications, we have tools to prove if they do. And we also take the question of cybersecurity very seriously. So that's why cybersecurity is one of the pillars for the testing. And on a country from the first two tests, where manufacturer can say, "Oh, you know what? We actually are not ready with our ISO5. So we kind of do it, but we don't want it tested because we're not ready. We won't advertise that we are okay with that." The cybersecurity is not something you can opt out, because we said if a device is in the network, it's a potential threat, it's a potential attack vector. If you are plugged into the switch, you will be scanned, no questions asked. So we produced 3 test plans that are publicly accessible, publicly available, where we actually explain what exactly are we testing for which particular part of the device. So if your device is an audio device, so for example you have a headphone amplifier, we have a whole set of audio tests and audio over IP tests that include ST2110-30, -31, so your subsets of AES67, for example, as well as timing and synchronization tests. So how your device actually operates with the common sense of the network, and also with the clocking. So how does it react to PTP changeover? Does your clock adequately react if we unplug the grandmaster and tell your device you should not become a grandmaster? Will it actually respect that directive? We also produced the same test plan for the control plane. So if you, for example, have a device that you're not sure if it claims to be NMOS compatible, but when you connect it into the system it does something weird, you can take this test plan and you run those tests. And the cool thing is that for both of those we have automated tools that are free and open sourced. I'm gonna get there. So for the cybersecurity test plan, same thing. We publish the tools, we publish the methods, we publish the actual tests, we publish the actual checkpoints. You know, like when on the PCB you have those measurement points, that's your measurement points for IP. And as I already said, we maintain, well, not we, but the community maintains the tools that we're using. One of them is the EBU Live IP Software Toolkit. It's the test suite for media over IP that is free and open source. It's available as SaaS, it's available as a Docker container, it's available as a C++ source code. You can take it, use it, it gives you a nice report, and you can check even the profile saying JTNM tested 2022. It will give you a report that is correlated with the actual tests. And same goes for the NMOS testing tool that AMWA supports and develops. This is a community-driven tool. It's an open source written in Python. And you can take it and you can point it towards the device and will actually use the APIs exposed by the device. It will if it's a controller, the testing tool will pretend to be a device that this controller can interact with and tell you if the commands that the controller is issuing are valid and how would real device react to those. So all this is part of the general initiative to make the world of media over IP more interoperable. In particular, we're using as our motivation the so-called EBU pyramid. Can we see it somewhere here or not at this show? It's on the AIMS website. It's on the EBU website. So the graphical representation, of course, shows you the layers of what we feel are important things to have in the media over IP interoperability. There is actually a document behind this pyramid. If you go to the source, is an EBU TAC 3371 document that gives you like 15 pages of explanation what each layer is and what we consider important in those layers. So if we say operational control, what does it exactly mean? And so these task plans are targeted towards these layers. So we'll tell a little bit more about what exactly we've done from the infrastructure perspective, how we actually ran the tests. So we used a true spine leaf layer 3 topology. So the network was completely routed. It was not a flat layer 2 network like sometimes people like to do. No, we went kind of all in. Every single device had its own subnet, so it must cross the layer 3 border to interact with any other device. So that's how we actually test if it's implementing routing properly, if it uses the gateway properly, if it uses valid MAC address, IP address, all the checksums. You wouldn't believe how many tricks people do sometimes on the IP layer just to get through with those tests. Yeah. So the network was 2022-7 fully supporting, so it was kind of with redundant links and with spine leaf, fully dynamically routed through BGP with layer 2 and layer 3 multicast management through IGMP and PIM. There was some additional VLANs and subnets designed for NMOS testing, and we also had a dual resilient PTP grandmasters, so we were able to switch from back and forth from 1 and 2 to see how the devices react to that. It was fully also driven with infrastructure as a code, so basically we pre-planned the network and then we propagated to the switches via Ansible, so all of that was brought in within a day. And that's actually one of those impressive things that I truly believe in, because we didn't have just like 3 switches. It was like 8 racks of equipment, and bringing those 8 tracks in like half day a network and then another half day for the endpoints. I think we are kind of getting there in terms of scalability, so that's good. Interesting feedback from the network team was that we actually seen a very big move now from 10 gigabits to 25 gigabits ports, and from 40 gigabits to 100 gigabits. So that's kind of interesting to know. So as I said, we used the 2 grandmasters from Telestream for PTP. And in terms of network services, we had for every single network interface a DHCP scope, and it was fully DHCP capable. So you plug it in the network, you get an IP address. It was a chore to go through and configure that, but when it was running, it was very, very good. So also network was fully NMOS compliant. It was providing all the services that you need, the DNS and the registry and the controller, everything was there. So a little bit about findings and results. The findings in the catalog, if you actually will bother yourself with just downloading it and actually looking at that, you will see this spreadsheet. And on the left, you will actually see, can I do a pointer? I can. So on the left here, you will see the device. You will see the make and the model of the device. You will see the actual software and hardware versions of the device at the time that we tested. We also enforced the policy that there were no engineering samples or special engineering firmwares. This is the actual firmware that you can get from the manufacturer and of the actual shipped product. At the time of the IBC 2022, it had to be a shipped product. So we had, for example, a product from one manufacturer that was released at IBC, but we made sure that the firmware that goes into that device is this one, and you can actually go and buy it. Then you have also the capabilities of the device. So is it a video device? Is it an audio-only device? Is it a hybrid device? Is it transmitter, receiver? And then you will have your check marks. So for the actual column, each column is a test in the test plan. So you can, when you see, for example, that this device showed for this particular test green, that says it's passed the test, or white, that says that it's not capable to show this functionality. You can go back into the test plan and read exactly, oh, so they've done this, oh, and this was the criteria, so this device did not perform according to the expectations in the test plan. And so for these parts, we tested, of course, everything that is in kind of common sense of network operations. Can I ping your device? Can I ping your device over layer 3? Some devices do not respond to ping. Some devices are an FPGA device that do not implement ICMP. Well, okay, that's valid, but from the kind of operational standpoint, I would like to be able to ping my device. So we thought that this is an important test. So something very generic, something very trivial as a ping is sometimes not so obvious for media applications. Can you freely assign an IP address, or do you have some hard-coded values that you cannot bypass? Can I assign a multicast address from the range that I personally selected? But also at the same time, if you allow a free assignment of the IP addresses, can I use some illegal IP addresses, for example, something in 2 to 4 range that is used for routing? So for example, can I just throw my multicast into an OSPF multicast range? If I can, I would expect at least a warning from a device saying, oh, you better know what you're doing right now because you're doing something illegal from the RFC standpoint. So all that, and of course also all the essence tests, so like video packet pacing, audio AES3 over IP with -31, ancillary data over IP, and of course there is redundant setups in -7, so we had some sophisticated testing where we kick every other packet from both legs, and we expect the device to recover from that. And so we had about, I'm sorry, we had 35 different vendors testing for that, with 84 products, and some of them are video, some of them are audio only. And what I was just about talking about the ping, you would expect that in 2022 something like DHCP is obvious. Well, it's not. It's like 67 devices only supported properly DHCP. So we saw various things like device not able to acquire an IP address, or even some devices faking that it acquired an IP address. So like there is work to be done there from the operational standpoint. So like bringing 16 switches in a very complex network took one Ansible script, but this took manual input for every single device that didn't support DHCP, and this should change. Because well, Anthony, how many endpoints of tens of thousands? Imagine if they fall into that 30% that didn't support DHCP. Anthony would come to me and he would say, why? And he does. Oh, so you do static. Oh, well, thank you. Thank you for ruining my example. Okay, thank you.
67% of them support DHCP.
Okay.
So again.
You're yeah. You're good. You're good. You're good. Yeah, and also we also made an introduction of the IGMP source specific for IGMP v3. We enforced IGMP v3 for a while now because of reasons, including immediate leave, and also we wanted to go source specific at some point, and we've done. And we're glad to see that a lot of devices already support that, but not as so many that we hoped for. Some statistics for your leisure reading at some point when you download those slides. In terms of, we had a lot of valid, a lot of invalid things, especially in the SDP. A lot of devices still do not expose an SDP. Some of them expose a not valid SDP that will get other devices confused. So this is something that the industry is looking at in as well. In terms of Dash 30, something that you would be interested for the audio, 96 of the audio only devices that were exposing Dash 30, not audio only, but audio capable devices were good. And in terms of Dash 7, we had a lot of troubles there with devices kind of acting weirdly where we were doing seamless production switching tests. This is something also to look into. So then the next tests, the next catalog is for the NMOS tests. Pretty much the same thing. We've tested a lot of APIs, so like registration API, connection management API, audio channel mapping API, control APIs, but also a lot of best practices and recommendations that the AMWA is publishing. For example, for secure communications, because NMOS is historically known to be insecure because it uses HTTP. Well, BCP 00301, that's a mouthful, addresses that by saying you shall use HTTPS. And we actually tested devices for both HTTP and HTTPS. And okay, so that's on the next slide. Anyway, we had 74 devices tested for media nodes capabilities, which is a lot, and actually a lot of devices that were tested for both now, which is good because the feedback from the team was when NMOS was accessible in the device, where we were able to use NMOS as a connection management tool, the tests for media applications were going very smoothly because you don't need to type in multicast addresses. You actually just make a connection on the controller, and that speeds things up incredibly for the testing teams. So only 12 devices, unfortunately, are currently already using the secure communication. This is something that we need to look at, especially after I show you the results for the cybersecurity testing, at least some of them. So in total, the team, we had a dedicated penetration testing team sitting behind at the back of the room, actively trying to audit and sometimes even break into some of the devices. Well, they didn't try to do it on purpose, but if it was a web interface, they were trying some default logins like admin passwords, root password. And in a lot of cases, they were actually getting into the devices, and they saw all sorts of different things. So in total, the scanners that they were used found 7,841 warnings. And after that, they went and talked to every single vendor saying, could you please explain why you have an open port for that? And if there was a valid reason, a valid functionality, then of course it's not a potential vulnerability. But also a lot of things that they saw there were quite weird, because some people just took a default IP stack and deployed it into a Linux machine, and that had, for example, a mail server that was never disabled. So you had a video playout server that was running a mail server on the media interface that nobody bothered to go in the back end and switch off. In some cases, we were able to get into the file system of the device and find the source code of the firmware stored on that device. And obviously I'm not telling you the actual examples because we're not publishing individual results, because that would be giving just keys to your apartment to a stranger. But we're gonna be publishing the overall kind of assessment. This is a distribution. So there were devices that were kind of okay, and there were devices that were not okay at all. So the delta between the two is big. And as I said already, some of the typical things are unpatched, end-of-life software, but also unnecessary features like the email server. We had an FTP server there. Web interface weaknesses, that's an obvious one. A web interface without any kind of login and password. And if you go on YouTube, on the VSF channel, there is a presentation from our colleague Gerben, who done at IBC, at the IP showcase, he's done a larger version of this presentation. And he was actually using an example. He was saying, well, a lot of vendors will actually say, well, this device is not intended to be used on a publicly accessible networks. This was a lab environment. But we all know how it works. One day it's a lab equipment, the second day breaking news happened, the queen dies, and suddenly this equipment becomes very, very operational in a matter of minutes. And so all this default configuration is immediately exposed to the rest of the network. But also in terms of, well, this device is not supposed to be on the internet. Well, if this is told to you by a vendor of a contribution encoder for remote production, you certainly should ask yourself some questions like, do they know what we're talking about here? Because even if it's a test and measurement equipment, imagine having a device that is exposed to the internet that has a 100 gig capable FPGA that sits in your media network, and an amount of havoc that you can cause by just abusing this one particular device. So anyway, that's, by the way, Jack Douglas from PacketStorm, if you know the guy. He had some fun during the event. So we think it's time to revise the BU pyramid, because the community actually came together and they said, look, some things definitely improved and we should send a positive message to the industry and to the users. But some things like the cybersecurity hasn't improved at all. Yes, a lot of vendors done their homework after the previous events, and they said, yeah, we understand, and we patch our software, and we've addressed some insecurities in our software. But there are new products, there are new vendors that came to the event, and that was new to them. They were exposed to a completely different mindset, and we hope that this will actually help them make their products better. So the aim of the event, and by the way, this is the team behind it, and then the QR codes for the catalogs. So we had a lot of people from all around the industry. We had network vendors there. We had people from test and measurement. We had people from broadcasters there. So the aim wasn't to shame anyone. The aim wasn't to show you, well, your device is bad. No, the aim was to make it a success for you, either through showing how you can do better, or by validating and saying you're doing good. And so a lot of vendors actually approached us. One particular vendor came to me after the event and they said, look, we're not going to publish our results, because a lot of vendors were allowed to not publish the results if there were specifically some issues that we're not proud of. So we gave them this chance and they said, look, we're not going to publish, but we knew that we had problems. We just came here to understand how we can improve and how we can fix our problems, so when next time we come, we actually get our badge, and we will be proud of getting this badge. So hopefully this will be useful for you if you're a representative of a broadcaster, an end user, or manufacturer. If you're considering coming to one of these events, you now know a little bit more about what is expecting and what is expected of you. We have the whole onboarding process. It starts about 6 months before the actual event. We come together with the experts. We revise the task plans. We onboard the participants. We have webinars on how to use the tools. We have the pre-testing where you are expected to execute the test plan, give us feedback. So it's very accessible. And we're also looking into ways to make it more sustainable, because putting this team even once a year is a process. So for example, Nicola here, he was one of the testers for the audio equipment, and he can tell you that was a tough week to grunge through. Like, that was awesome, but that was like 13 hours of testing every day. Yeah. So thank you for listening, and hopefully you can benefit from that in some way. Yep. Yeah, if you have any questions, go ahead.
So, a lot of protocols have reference tests, like reference devices. Is there a 2110 reference from means or from the J10M that is like a that can be benchmarked against?
That's a very good point. A lot of so we are actually working with Alma about that, and they already received the feedback that the test tool, of course, is very good. But for example, a reference implementation of an API that users can play with and understand how exactly is implemented, not just reading the spec and interpreting it every single time from scratch, is good to have. Now, there are no reference implementations of 2110 just because of its nature. It's kind of, so our test tool is open source, but it's not relying on the precise features that are required and usually provided by the hardware. So 2110 is kind of hard to implement in software because of the packet pacing requirements. And so we're using, sorry, I kind of losing my voice. So we're using a well-known, well-behaving devices from the industry that we tried and tested before as the reference devices during the events. But of course, we're not expecting anyone to own these devices in the lab to test against. So yeah, it's a challenge. No, I don't have an answer for that. Okay. Hopefully you had a good time. Yep.
Oh, goodness gracious, I'll be an elbow. Good day, sir.
So good to see you. It's okay. I was just on the phone with them a couple of hours ago. A couple of days ago it was pretty stressful, but when there was attack on the left bank.